Very good evening, everyone, and welcome to the NPTEL's 8th live interactive session on the course Engineering Metrology. The course instructor for this course are Professor J. Ram Kumar and Professor Amanding Singh Oberoi. And I am an additional TA, Shubham Jaiswal. I am a research scholar in the Department of Material Science and Engineering at IIT Kanpur. So in this live interactive session, we will be going to solve some samples problem related to your weekly content, which will in turn help you to solve your weekly assignment. As this is the live interactive session, I hope for the interaction. So before proceeding towards the problem, we will quickly recapitulate what we have seen in the last week. Okay. So in the last week, we have seen the strain measurement. In strain measurement, we have seen the introduction to the strain. That is what is meant by strain. That is change in length to the original length. Okay. So and after, also we came to know that the strain is a dimensionless quantity, or sometimes it is referred as or sometimes it is represented in terms of meter per meter or per. Okay. So after that, we have seen the load cell. So what is meant by load cell? How it used for measurement of the force. So it works on the principle of the change in cross section results in the change in resistance of the material. So the equation is R L by X. L is the length and AC is the cross sectional area and R is the resistance. So after that, we have seen some strain gauges like metal foil strain gauge. So in this metal foil strain gauge, we use a metal foil for measurement of the strain. So in metal foil strain gauge, one more thing is that the resistance of the strain gauge increases when put under the tensile loading or tensile stress. So resistance of increases when put under tensile stress. Why is it happening? Suppose so this is our component, and if we are applying the tensile load, okay, so its length is increasing, okay, and at the same time its area, the cross sectional area, is decreasing. So here the length is increasing and cross sectional area is decreasing, so which in turn results in increasing the resistance of a material. Okay. So after that, we have seen the term called gauge factor. So gauge factor basically represents, it measures the amount of resistance change for a given strain. Measures the amount of resistance change for a given strain. So we can represent it as also we can represent gauge factor in terms of Poisson's ratio as 1 + 2 mu. Okay. So after this, we have seen the working of load cells. Working principle of load cell. So it's like in this we have seen that the load cell is made up by bonding the strain gauges to the elastic material. Then we have seen the resistance measurement, how the resistance is measured. So after that we went to the new term, that is the torque measurement. So in torque measurement we have seen the different instruments that is used for measurement of the torque. Like if we want to measure the torque on static component, we use torque arm and the force transducer. Then similarly for the dynamic measurement or for engine dynamometer, we use the instrument called dynamometer. It works on the principle of torque, the absorption of torque or converting the torque in the form of heat. After that, we have seen some one active transducer, that is PZT, also known as piezoelectric transducer. It is used for measurement of dynamic force, pressure, and acceleration. Used for and acceleration. So after this strain measurement, we went to the new measurement technology that we use in the tool room and in the industry more widely, that is optical measurement. In optical measurement, we have seen what is light. So light is nothing but the electromagnetic radiation. And the wavelength will be in between 400 to 700 nanometers. And the element that defines the light is known as the photon. So this we have seen in the basic, that like in the introductory part. Then we have seen some terms related to the light, like reflection, refraction, interference, intensity, or diffraction. Some more like polarization, etc. So after this, we went to see the principle of microscopy, like how the microscope works and what are the different types of microscope that we use in our industries. Okay. So then we have seen the principle of microscopy. So in this principle of microscopy, we have seen that we get a two-stage magnification in the microscope. One is through the your objective lens, and second one is through your eyepiece. Okay. After that, we have seen the essential features that that optical instruments must have. Like what are the different types of parts or instrument that the optical instrument should consist of. Okay. So if I write principal features of optical measurement should have. So in this we have seen like the optical instrument should have a light source. Also, it should have a condensing or collimating lens. Also, it should have a stage for keeping our workpiece or sample. Similarly, it should have a projection optics like lens for magnification and mirror for reflection, and mirror for reflection of the light. Okay. Similarly, to view our sample or the workpiece, we should have a screen or eyepiece. Similarly, and to measure the dimension or to record the profile and all these features of the our sample, we should have the measuring device or recording device. So this we have seen in the basic optical measurement. Okay. So after that, we have seen some instruments, like some optical instruments, like tool maker's microscope. Okay. So in tool maker's microscope, it's generally used in the shop floor inspection or measurement of the tool or the measurement of the parts. Shop floor inspection, measurement of tools and machine parts. So, and we can measure the shape, size, and angle and position of the workpiece using the tool maker's microscope. So after that, we have seen the what are the types of illumination that is being used in the tools maker's microscope. So first we have seen that is the contour illumination. Then second, we have seen the surface illumination. And third one is the simultaneous surface and contour illumination. So after this, we went to see the next device in the category of optical measurement, that is profile projector. So the profile projector is used for comparison or inspection. So it generally, what it does, it projects the 2D magnified image of a workpiece or a sample. Projects 2D magnified image. So after this, we have seen some the other devices like optical flats and optical square. So in optical square, so we use optical square to change the side of view with different angle. So inside optical square, we use a pentaprism. Okay. It is a pentagonal shaped prism. So the name pentaprism. So what it does, it reflects the light internally inside the prism itself, and it will reflect that light by an angle of 90 degree to that of the incident beam. So incident ray reflected internally and emerges from the square exactly at 90 degree to the incident beam. So as the pentaprism reflects the light internally, so there will be no error or no effect of any tilt or misfit of the instrument. Okay, so so the error, like if we have the tilt error or some misfit error, then it will not affect the angle that is being reflected by the pentaprism. Okay, it will be always be 90 degree to that of the incident beam. Okay, so after this, we have seen the optical flats. After covering this optical measuring instrument, like in optical flats, after that we have seen some scales, gratings, and reticles. So after this, we went to the new area of metrology, that is nanometrology. The metrology at nano level, that is to the power of 10⁻⁹. Okay. So to measure this much accuracy, we need a device which should have a least count of 1/10 of the what we want to measure. So 1/10 of tolerance of values to be measured. So in this nanometrology, what we have seen the importance of nanometrology, why we need a nanometrology in our day-to-day life. And after that, we have seen the nano dimension, like the dimension of the different things like bacteria, virus, human hair, atom, and all these things we have covered in the nano dimension. So after that, we went to see the different classification of the nanostructure. In this one, we have covered zero-dimensional, one-dimensional, two-dimensional, and three-dimensional nanostructure. Okay. So after that, we have seen some measuring techniques or a measuring instrument that we use for the nano level measurement, such as AFM, ACM, STM, and TEM, etc. So this we have covered in our last week content. So now moving towards solving problem. So the first question is, the Young modulus within the elastic limit is inversely proportional to the stress by strain. Mr. Roderick, is it true or false? Am I audible? Yeah. Thanks, Raji, for the response. You are right. The correct answer is false. Why is it so? Let's see. If we see the stress strain curve, okay, so this is proportional limit, this is up to this elastic limit. Okay, so what does the Hooke's law say? That the stress is directly proportional to strain, and here the strain is the independent variable. Okay, so and its effect or the compensating component is the resulting component is the stress. So and if we replace that proportionality sign, we can see sigma by strain, and this E is known as the Young's modulus. So here from this equation, we can see that the E is directly proportional to the sigma by E. But in the question, they have mentioned that elastic limit is inversely proportional to stress by strain, so which is false. So moving to our next question. In optical square, mirror is kept at angle of 90 degree with respect to the incident ray of light. Is it true or false? What do you think, Mr. Roderick? You are not audible, Mr. Roderick. Your voice is low. What do you think? You can use the chat option. Okay, let's see. So here they are saying that in optical square, mirror is kept at angle of 90 degree with respect to the incident ray of light. Okay, so here we can see that they are using the term optical square. Okay, in optical square we use pentaprism, not a mirror. So this statement is absolutely false. Okay, but when does we use the mirror? In case of optical flat. Okay, so in the optical flat we use a very highly finished glass or quartz, and the highly finished glass or quartz material surface are the flat, and that too with at a high degree of flatness. So in only if we use the optical flat or the surface mirror, so what will happen if there is any, like here you can see, here I have one inclined surface. Okay, so if I keeping my mirror on it, okay, suppose if there is any error, or if there is any error in the alignment, so we can see that error in the in the reflection. So if the incident ray is hitting to the mirror, it will, if there is any error, baseline error or tilt error, then definitely we will not get the reflection at 90 degree. So it will be somewhat different than the 90 degree. But in case of the optical square, like we use a pentaprism. So mirror. So in case of pentaprism, we can see that the incident ray here, incident ray, this is reflected ray, is exactly at the 90 degree. Is that clear, Mr. Roderick?
Yes, it's clear.
Yeah. So moving to our next question. The load cells are used for the measurement of load, power, velocity, force. What do you think, Mr. Roderick? Why does we use load cell?
I think used for force, for measure force.
Yeah. Yeah, Mr. Roderick, you are correct. The load cell that we use are for the measurement of the force. So load cell, let me write all the term: load, power, velocity, and force. So here we can see that force we can measure using the load cell. Velocity or the speed that we can measure using the tachometer. Power we can measure using the dynamometer. In this, first we will measure the torque, then we'll use the equation 2 pi mt 60, okay, to measure the power, and load we can measure using weighing machine and some other instruments. So moving towards next question. Which of the following statement is not true with reference to nanodimension? If the grain size is smaller than the electron mean free path, the electronic conductivity as well as temperature coefficient increases. Due to the contribution of grain boundaries at nanoscale, materials exhibit superior mechanical strength and ductility. Thermodynamic properties also undergo sea change. Tribological properties are also affected since the interacting material are in the nanoscale. So what do you think?
I think it's the second option, due to the contribution of grain boundary at nanoscale, material exhibit superior mechanical
Property and ductility. Okay, Mr. Roderick. Is there any other option? Anyone? Mr. Rajneesh? Okay, so let's see one option one by one. So if the grain size is smaller than the electron mean free path, the electronic conductivity as well as the temperature coefficient increases. Okay, So let's see, we have not seen this one, so we don't know, so we will not mark anything. Then due to the contribution of grain boundaries at nanoscale, material exhibits superior mechanical strength and ductility. Yeah, it's true. Okay, this one is true. Like we get superior property if the material goes to the nanoscale level because of the grain boundaries and some other interaction. Similarly, that thermodynamic properties also undergoes a change due to the interaction of surface energy and strain energy. So definitely the thermodynamic properties also undergo sea change. This is also true. Similarly, the tribological properties are also affected since the interacting materials are in the nanoscale. Okay, so suppose if I am having a one rod and here I am having some nanoparticle. Okay, and I am moving it in on the disk. Okay. So the definitely if the nanoparticles are very hard or coated on the surface, definitely changes the tribology, means it affects the tribological properties of the interacting material. Okay, so this is also true. So if these three are true, then the not true option is this one. That is, if the grain size is smaller than the electron mean free path, the electronic conductivity as well as temperature coefficient increases. So, moving to our next question. The scanning tunneling microscope is used to measure one-dimensional, two-dimensional, or three-dimensional topology of the specimen, or all of these. What do you think, Mr. Roderick? Anyone? Okay, Rajneesh, what do you think? Mr. Roderick?
Hello.
Yeah.
I think that is for two-dimensional measurement.
Okay. Okay, so the scanning tunneling microscope is used to measure which of the following topology of the specimen. So let's see, like if I have a sample like this, okay, like if I keep it on the table, okay. So let's see, we have a pivot or a probe, and here we have some arrangement to detect the reflection angle of the laser, and that we will process using the processor. So if we are measuring the topology of the specimen, so we can get a three-dimensional topology of the specimen. Okay, so like we can get it's length, width, and similarly some depth also. So we are getting the three-dimensional topology. But in case of the some optical, some not all, but in some optical devices, we can get a one dimension. But in case of the scanning tunneling microscope, we get the three-dimensional topology, and it works on the principle of quantum tunneling. Yeah, yeah, Mr. Roderick, would you like to say something?
No, thank you.
Okay.
I was thinking it was two dimensions. Sorry.
No. It's three-dimensional. Okay. Now moving to our next question. The element that defines the light is called electron, photon, crystal, waves. Yeah. Yeah, Mr. Roderick, you are correct. That as we have seen that we have recapitulated what we have seen in the last lecture. In that also I clearly mentioned that the element that defines the light is known as the photon. Is the small energy packets. So moving to our next question. The phase grating consists of irregular shaped or square shaped or triangular shaped or spherical shaped contiguous grooves similar to spectroscopic diffraction pattern. Okay. So the phase grating that we use is of triangular shape. Okay. We use a triangular shape continuous groove similar to the spectroscopic. Okay. Like this one, triangular shape, we use phase gratings, and it gives the shape. It is similar to that of spectroscopic diffraction pattern. So moving to our next question. One major limitation of laser interferometry is that it does not have constant wavelength. It generates only single wavelength. It generates multiple wavelengths. Its wavelength cannot be predicted. Anyone? Mr. Rajneesh, Mr. Roderick. So, okay, let's see. As we are talking about the laser interferometry, so in laser, we use monochromatic light. And it has single wavelength. So this option cannot be true. Okay. So its wavelength cannot be predicted. We can predict its wavelength. We can definitely predict the wavelength of a light. Okay. So or the laser. So this cannot also be true. So it does not have a constant wavelength. Okay. As we are here, we are using a single wavelength. So this cannot be true. So the only option remains is it generates only single wavelength. So why is it so? Why it's the major limitation of laser interferometry? because we can't use the method of exact fraction cannot be for measurement. And also the spot size or beam size of laser will be very small, so we cannot cover the wide area or the broad area for the measurement. So and limited. So this is the major limitation of the laser interferometry. So moving to our next question. For measuring torque in rotating parts, which of the following is used? Tachometer, accelerometer, dynamometer. Yeah. Would you like to answer, Mr. Roderick?
None of the above, or none of them.
So, for measuring the torque in rotating parts, okay. So we are talking about the torque in rotating parts. So some rotating parts will be involved. So in that case, we use dynamometer for rotating parts, like engine dynamometer and some other types of dynamometer that we use, rotating parts. So if you want to measure the torque of the what we call static component, for static component we use torque. So what does we use? We use torque arm and force transducer. Torque arm and force transducer. Similarly, we use tachometer for measurement of speed. Similarly, accelerometer is used for measurement of acceleration. So the correct answer will be the dynamometer. So moving to our next question. The element that makes a microscope a measuring instrument is objective lens, reticle, light beam, none of these. What do you think, Mr. Rajnish? Mr. Roderick? Okay. Yeah, Mr. Roderick, you are right. The element that makes a microscope a measuring instrument is reticle. Okay. So using light beam, we can get the reflection or we can project it on the screen. And similarly, using the objective lens, we can get the magnification, but only the reticle. Like if you have seen the microscope, like if you see through the eyepiece, you will see something like this. Like suppose this is our surface. Okay. So you have been seeing some lines like this. Okay, and we will have some markings on it. Like this. So these markings are repeatedly spaced, and using this marking, we can easily measure the dimensions we can do the measurement. So only the reticle is the one that makes a microscope or measuring instrument. So just if the reticle is not there, we can't do the measurement. We can just simply see and observe what is there. Okay, but if we have the reticle inside our eyepiece, we can definitely use it for measuring. Like we can measure the height of this one from this the surface. We can measure the height. Similarly, we can measure the width also for this surface. Okay, like we can measure the width. Okay, so these things we can do if we have the reticle in our microscope. So moving to the next question.
What is the objective of objective lens?
Yeah, the objective lens, we use it for the magnification, through which we see and we magnify the image. Okay, let's see. Okay, so suppose, okay, so okay, let me draw the quick microscope for you. So suppose this is your table. Okay, you have kept the workpiece here, and you will be having some lenses like here 5x, 10x, like 20x. So these are the objective lenses. Okay, that we use for the magnification. And here at the top, you will be having the eyepiece. Okay, you can have a light source here, or you can have a light source from the bottom like that, or you can also have a light source from the top, depending on its type. You can use the objective lens for the magnification of that image, but only the reticle which will be placed inside your eyepiece or here, so that only will be having the marking on it, and that mark, using the help of that marking, we can measure. Is that clear, Mr. Roderick?
It's clear, sir. Thank you.
Yeah. So moving to our next question. Calculate the amount of strain generated in a string if a force of 10 Newton changes its length from 4 centimeter to 4.2 centimeter. So please calculate and tell me the answer. It's very simple question. Some values, don't focus on some values, that can be the misleading one. Okay. Mr. Rajneesh, Mr. Rodrigue, what is the answer? Okay, let's see. So, what they have seen, they have one string, okay, okay, and they have applied a force of 10 Newton, okay, 10 Newton. So what they are saying, the initial length, okay, the initial length, like this length is 4 centimeters. Okay, and what they are saying, after applying a load of 10 Newton, the length of the string changes for 4 centimeter to 4 point. So let's say this is the change length. Okay, this much length has increased, that is 4.2 centimeter. Okay, so they are asking us to calculate the strain. So the strain is nothing but change in length by original length. So this is final length minus Yeah, Mr. Rodrigue.
Third option, sir.
Yeah. Initial length divided by initial length. Here we can get 4.2 minus 4 divided by 4. 0.2 divided by 4. This comes out to be 0.050 centimeter. So the correct answer will be the second one. That is 0.050. So moving to our next question. Is the measure of load being applied on a given body? Stress, strain, modulus of elasticity, none of these. So, yeah, Mr. Rodrigue.
It's strain.
So the stress, the correct answer is the stress is a measure of load being applied on a body. Okay. So suppose I am having one workpiece like this and I am applying a load, okay, on this force. Okay, so the stress is nothing but force upon area. So how much force I am applying will generate the stress inside it. Okay, so the stress is the measure of load being applied on the given body. If we consider strain, it is change in length upon original length. So it does not talk about the load, but as we are applying a load, so definitely there will be a strain, and that to compensate the strain, or to compensate that the applied force, the stress will be induced in the material. So the measure of the load being applied on the body is stress. So moving to our next question. The working principle of load cell is change in length leading to change in resistance, change in temperature leading to change in resistance, change in resistance leading to change in temperature.
Changing in length leading to changing in resistance. The first option.
Yeah, first option. Okay. What do you think, Mr. Rajneesh? Okay. Let's see the load cell. If we write the resistance equation like in terms of the length and the cross-sectional area, we can see that from this equation, the change in length, okay, changes the resistance of the material. So the correct answer will be the change in length to change in resistance. That is for load cell. So can you tell when does we use the change in temperature leading to the change in resistance? Mr. Roderick, where does we use that principle?
In the temperature measurement.
Yeah. Can you specify the device or instrument?
Thermocouple? No.
No. Generally in RTD. Okay. Resistance temperature detector, we use this principle, that is the change in temperature leads to the change in resistance of the material. Similarly, can you tell me the example of change in resistance leading to the change in temperature? So the change in resistance leading to the change in temperature, this principle we use in our furnace coils to increase or decrease the temperature. Okay, in the so now moving to our next question. The most effective and a simple method to measure a torque is to use a torque arm, to use a force transducer, to use a torque arm and force transducer.
We can use the force transducer.
So they have not mentioned about whether it is the static torque or dynamic torque. Okay. So or means a rotating torque. So here we can and depending on the options given, it is a state of static torque. Okay, like they are asking to measure the torque on static component. So in static component, we use the torque arm and the force transducer. Like we can't use the torque using the torque arm alone or the force transducer alone. We need to use both of them together to measure the torque. So the correct answer will be to use a torque arm and a force transducer. So moving to our next question. It is same. Okay. One potential source of error in torque measurement is the presence of undetected static torque. Is it true or false? What do you think, Mr. Rajneesh?
It is true. Hello.
Yeah, Mr. Rodrick.
I think it's true.
Yeah. Yeah. If we are not if our strain gauge or the instrument is not able to detect any static torques. Okay, if it is detecting only the dynamic torque, then definitely there will be some error will present in the measurement. Okay, because it is not considering the contribution of that static torque in the total torque. So definitely the answer will be the true. That is the one potential source of error in torque measurement is the presence of undetected static torque. So moving to our today's last question, which of the following are the essential features of an optical instrument? A light source, a condensing or collimating lens, a viewing screen, or an eyepiece to receive the projected image.
All of the above.
Yeah. Okay, Mr. Rodrick. Any other option, Mr. Rajneesh? Okay, so these things we have already discussed in the beginning, like what are the different components of optical instrument and why they are being used. So if we see that, here we definitely we need a light source. Okay, so light source also we need. We need a condensing lens. Also, we need a screen or eyepiece for the projection. So the correct answer will be for that question will be correct answer will be all of these. So that's it for today. So we will meet in our next session. We'll try to solve some sample problems related to that. We will continue. So, yeah, Mr. Roderick.
About the registration for the certificate, is it possible for someone to pay for another person? Like, I will just send
Mr. Roderick, can you use the chat box? I'm not able to hear you properly.
Thank you.
Yeah.